Hello, I welcome you all to this another interesting screencast. We have four problems, all coming from the same figure, and all these problems are coming from the Engineering Mechanics Statics textbook, 13th edition by R.C. Hibbeler. The first problem says determine the angle theta between cables ABA and AC. The second one, determine the angle phi between cable AC and the strut AO, and the third one, determine the projected component of force FAB along the axis of the strut AO. Express the result as a Cartesian vector. The fourth one, determine the projected component of FAC along the axis of the strut AO. Express the result as a Cartesian vector. So when we talk about projected, all right, we can either use an angle if an angle is there, or we can use the dot product. So in this particular case, we're going to use the dot product for the two cases, the third and the fourth. The first one, we are also going to use the dot product as well to find the angle between those cables and between the cable and the strut. Right, so we are going to let A be our reference. So we change our reference again. You don't have to do this if you don't want to. You can still work with the reference given. For me, I'll change my reference. I'll say my reference. I'll have my new reference. My new reference will be A and it's 0, 0, 0. Therefore, I will need to find the position vector AB, AC, and AO. So RAB, which is also equal to RB. So this is just equal to, let me just draw my coordinate there. So I'll have something like this. This is my new coordinate. Something like so, and then something like so. This is not bad. All right, let's label it. So this is our Z prime. This is our Y prime. This is our X prime. Great. So RAB, what are the coordinates of B with respect to A? All right. So it's a -3 in the x-axis, -3i. In the y-axis, it is a -6j. And in the z-axis, we have a 4 -2. That's a 2, so it's a +2. Okay. Let's find this magnitude using Pythagoras theorem. So this is 9 plus 36. So 3 squared plus 6 squared plus 2 squared, 49. So this is 7. That's the magnitude. All right, let's work out. Let's find RAAC. RAC, what is our C? Our C, let's find those components quickly. C, look at C. See, there's an angle there. So we have this distance that we need to calculate, this one. Okay. And then we have another one, this one. Okay. Great. So let's find that. We need to find that quickly. Great. So this one is going to be equal to this angle there, it is 60, so this becomes 5 sine 60, and this one is 5, this is 5, let me see, this one, sorry, this one This one is 5 cos 60. This one is 5 cos 60. Okay, the angle is there. Okay, and then this one is 5 sin 60. Okay, like so. 5 sin 60. Cos 60 we know is 0.5, therefore this is a 2.5, right? It's a 0.5. Alright, so 5 sin 60, then that one cos. Great. So RAC is going to be equal to, the x component is 2.5, 2.5i positive, the y-axis is minus 6j, the z-axis it is 5, is let me subtract, let me write down this, 5 sin 60, 5 sin 60, this is a 4.33. Alright, so we have a 4.33, that's 5 sin 60, 4.33. So 4.33 minus 2, of course we get a 2 minus 2, 2.33. Okay, there we go. Then let's work out the magnitude quickly. Magnitude will be 2.5 squared plus 6 squared plus 2.33 squared, and square root of that we have a 6.9. 6.90. So 2.5 squared plus 6 squared plus 2.33 squared, square root of that 6.9. Great. Then we have the last but not the least, RAO. RAO also equal to just RO. This one, in the X there is nothing, in the Y we do have something, in the Y it's a minus 6j, and then in the Z it's a minus 2k, and the magnitude of this magnitude is just going to be equal to, that's 6 squared plus 2 squared, okay, square root of 40. So I'll just leave it as 40 square root of 40, like so. Okay, I think this is enough. So we can go ahead and start working out. So let's go to case 1. Case 1 is 2-122. Quickly. Alright, great. What do we have here? The angle between cables AB and AC. Alright, these forces, so we'll have AC, AB will have a force in this direction like this. Let's write them down. We can write them down. Do we have to? Okay, let's write down the forces. I'll not show the forces here because the figure is not that very big. Everything will get clustered and so on. So let's write down the force using this. Using, to say the unit vector, a formula for unit vector. A force, converting a force is force vector is just this magnitude times the unit vector, right? And the unit vector is just equal to the position vector divided by its magnitude, and I have this information here. Alright, so let's write down, but for the angle we can either use any vector, right? It doesn't really matter. So instead of using force vectors for the angles, we're just going to use position vectors, right? So we have RAB, which is equal to a minus 3i you just go directly and do the dot product. So dot RAC, okay, and this is equal to the magnitude of each one of these times the magnitude of RAC, okay, cos the angle, and therefore cos the angle itself will just be equal to, let's plug in these particular values. Cos angle, if we made it subject to the formula, let's plug in the vectors. So we have minus 3 I 6j plus 2k dot the other one there, which is RAC 2.5 I minus 6j and then plus 2.33k, and everything divided by, okay, everything divided by the magnitude of RAB, which we found as 7, then by the other one. So this one, there is no better space here. Let me start here. So cos theta is going to be equal to minus 3I minus 6j plus 2k dot 2.5 I minus 6j plus 2.33k. Okay, and then this divided by, let me use a straight line, this divided by what is this, magnitude of 7 by 6.90. Alright, therefore if we are to work out this, we'll find that theta, making theta subject to the formula. So let's start working out. You know how to do the dot. So we have minus 3 times 2.5, okay, minus 3 times 2.5 plus minus 6 times minus 6, of course, plus 2 times 2.33, and everything divided by 7 times 6.9, then cos inverse of that, we get a 46.64. Okay, so that's the first answer. So minus 3 by 2.5 plus 36 plus 2 by 2.33 divided by 7 by 6.9. Okay, then cos inverse of that, we have 46.64. Great. So that is the first part. So let's go to the second case. That's case 2, which is 2 dash 1 2 3. Okay, sounds funny, 1 2 3, right? All right, as if we are counting, right? So determine phi. Here it is the angle between AC and the strut. So again, we already have those, we've already calculated. So we just say, just go directly into the formula. So you just say between the cable AC, so just say RAC dot RAO. This is equal to the magnitude of RAC times the magnitude of RAO then cos phi. Okay, then cos phi is just going to be equal to RAC, we said is a 2.5 I minus 6J plus 2.33K. Okay, then dot RAO. We said is minus 6, so we start with 0I minus 6J minus 6K. Okay, and then everything, we are dividing everything by the magnitude. I bring this line here like so. The magnitude of RAC, which is 6.90 times root of 40. Therefore, phi will just be equal to, let's work out that, 2.5 by 0, of course it's a 0, then plus 36, and then plus minus 2 by 2.33. Okay, then divided by 6.9 times root of 40. Alright, then cos inverse of that, we have phi is 44.10. Alright, so this is the angle. Let me do it again. So 36 plus 2.33 by minus 2, so divided by 6.9 by root of 40. Okay, cos inverse of that 44.1. Okay, so this is the angle between the AC and strut AO. Alright, so let's go to the third case. So case 2-124. This is case what? This is case 3. So case 3, sorry, this is case 3-2124. Okay, so here we have been asked to find the projected component of FAB along the strut AO. Alright, so we need the unit vector AO. Unit vector AO is just going to be equal to minus 6J divided by root of 40 minus 2K divided by root of 40. Alright, so now let's write down the first vector AB. So we are just multiplying the first vector itself by the unit vector along that direction. So this is just going to be equal to, what's the magnitude of F is 70 times, let me start with the unit vector RAB. So we have a minus 3 divided by the magnitude 7 times the force itself 70 I. Okay, and then we have minus 6 divided by 7 times 70 J, and then we have a plus 2 divided by 7 by 70 K. Alright, so therefore if we rewrote this, then we have the following expression. Just multiply there and there, so this becomes a minus 30 I. Okay, then minus 60 J, and then a plus 20 K. So this is the force vector, and we have the unit vector here. So we are just going to dot and the 2, so that we get the projection along AO. So say FAB dot the unit vector AO. So this is going to be equal to minus 30I minus 60J plus 20K dot 0I minus 6 over root of 40J minus 6K over root of 40K, of course. Okay, so what do we get when we do this? So let's work it out. We know how to do the dot product. So minus 30 times 0, of course, is 0, and plus 60 minus and minus 60 times 6 divided by root of 40, and then we have plus 20 times minus 2. So I'll start with just a minus. Let me just say minus outside. So we have 20 times 2 divided by root of 40. Of course, we are going to get a scalar value here, 50.596, and when we round it off, it becomes 60, like so. So let me again multiply. So we have 60 by 6 divided by root of 40 minus 20 by 2 divided by root of 40, 50.6. Okay, so there we go. But we have been asked to express this as Cartesian. So as Cartesian, we'll say FAB parallel to AO is going to be equal to this result that we just found, dot AO, okay, dot AO dot AO, okay, all this, then we are going to be multiplying this by the unit vector AO again. Okay, so this is just going to be equal to 50.6 times minus 6 divided by root of 40 j minus 2k divided by root of 40. Alright, and therefore the final solution becomes equal to, just move this a little bit somewhere there. The final solution for this becomes equal to FAB parallel to AO will just be equal to so 50.6 times 6 divided by root of 40. So this just becomes a 48 minus 48I, and then we have 50.6 by 2 divided by root of 40. This again becomes a minus 16j. This is j, not I. This is a j. This one is a k, and this is all. What units are these? This is pounds. So we will express this as a force vector. Okay. So let's go to the next case, which is case number 4. That's 2-125. Alright. This is a little bit long. Sorry. The next one, of course, we have the force vector itself. The force vector FAC is just going to be equal to FAC is equal to FSC. We have a 2.5 divided by 6.9. What's the value for 60? 60i. Okay. Then we have a minus 6 divided by 6.9 by 60 j. Then we have a plus 2.33 divided by 6.9 times 60 times 60k. Therefore, FSC is just going to be equal to FSC is equal to so 2.5 divided by 6.9, 2.5 times 60 divided by 6.9. So this just gives us a 21.74 I, and minus 2.5 by 60 divided by 6.9. Okay, and then we have 6 by 60 divided by 6.9. This is a 52.17j, and then we have plus 2.33 times 60 divided by 6.9. This is a 20.26k. Alright, so there we are. We have this expression. So what we just need to do now is to fit it in our equation. So we'll say finding FAC, that is parallel to AO. This is just going to be equal to FAC dot, this is a vector, dot UAO, then times the unit vector itself, AO. Okay, therefore if we do the calculation, then we are going to have the following. This will be equal to put the calculations. You already have the unit vector. This is the unit vector here, okay, that we are plugging there, and then later on again you come and multiply. Okay, so we start with those in the brackets. So let's multiply. So minus 52.17 times, so minus, so just 52.17 times 6 divided by root of 14. Okay, and then we have a plus, so that becomes minus 2 times, or 20.26 times 2 divided by root of 14. So we have 43.08. Then I multiply this, so I'll say, let me just write it somewhere, 43.09. Then I'll multiply that with a unit vector, so I'll say 6 times 43.09 divided by root of 40. So this gives me a 40.88. That's a minus. That's a minus. That's a 40. That's minus 40.88 j rather. We don't have any I. And then we have 43.09 times 2 divided by root of 40. That is minus 13.63k. So all this is pounds. Okay. All right. So determine the So projected component, of course, this FAC vector force dot UAO, this is equal to 43.09. Okay, 09 pounds. Let me just confirm it again. So we have that is 52.17 times 6 divided by root of 40. Okay, minus 2 by 20.26 divided by root of 40, 43.09. Alright, I think this is about it. I guess we are done. Let's outline the solutions. So we have the angle in the first case. This is the angle between the two cables, and then this is the angle between the cable AC and the strut, and then we have projected component there. We have this part, that other part is too long, so FAB dot UAO, we say this equal to 50.60 pounds. So that one, we also found this component, which is this one here. Let me use red. So that was a projected component, 50, and then the parallel, the converting it into a vector formatting along that same strut. This is the vector component of that force projected, and then also again in this other case, this is the projected component, not in vector formatting, and this magnitude is here. Okay, scalar quantity. I think this is about it, and I hope the video was helpful, and if it was, give me a thumbs up, like my video, continue subscribing and liking my channel. Bye bye, and I'll see you in my next screencast.